Hello, everyone. Welcome all of you to the first sessions of today afternoon event. So first of all, for the first sessions, I want to introduce to all of you to Associate Professor Nguyen Minh. He is a lecturer from Hanoi University of Science and Technology. And he is also currently a professor at School of Electrical and Electric Engineering. And Mr. Minh has a master and doctorate in the fields of digital system design and verification. And currently, he is teach at the fields of digital system designs at Hanoi University of Science and Technology. And now, please give him a big applause to welcome him to the stage.
So thank you, MC. Good afternoon, everybody. Today I would like to show you our works on using ChatGPT, OpenAI ChatGPT, to design a spy neuron network accelerator. And we also show you how can we speed up the design process using open source framework. So this work is contributed by many people in my lab, EDIBK Laboratories, School of Electrical and Electronic Engineering. So I show their name here. Something wrong. Is it? Doesn't work. Doesn't work. Okay. Okay, now it's work. So in this talk, I will firstly introduce you the fundamental of spy neural net. It's a new type of neuromorphic computing, which targeted in ultra low power neural net computing. And here I will show you our design requirement, what should we do, and also the architecture. And then in the next section, I will talk about the design methodology that leverage OpenAI as the tool. And then after having the design, we also need to synthesize and physical design the chip. So we show you how to speed up the process using an open framework. It is a RISC-V-Based framework. And then some conclusion and the challenges that we still need to face in order to use it, use the open framework in a real chip. So let's first start with very basic knowledge about spy neural net and the neuromorphic computing. So here you see our brain, and our brain is organized into a kind of column. And it is a biological cell. And in this cell, you will see that the neuron spy or fire a spy to another neuron. And now we want to mimic our brain using some kind of chip, the digital chip. So this semiconductor neuron. So here you can see that we want to, let me see. Okay. So here, for example, you have biological, where is it? No. So let me move here. You have the biological cell, and we want to mimic it using this kind of digital cell, and we call it a core, neuron core. So here you see the neuron. Here, one of these is a neuron, and we have the axons that connected to the neuron. We can go to the next slide to see it. So here you see the neuron, and the neuron is connected to another neuron based via the axon. And here we have a connection which is a synapse. cell. Now we want to mimic this using electronic elements. So here we have the SPI going from the network and go to the buffer, and then via the synapse connection go to a neuron. And then the neuron will calculate, compute, actually they accumulate the SPI, and if the voltage, the potential greater than a threshold, then the SPI will fire, will be fired by a neuron. So it's here's the architecture that invented by IBM, and we call it true knot architecture. It's a neuromorphic architecture. So here is more illustration of that. So you see that the SPI is the neuron fires SPI to another neuron, and also in the electronic chip, you will see that the same thing happen. So we have the SPI going from the axon via the synapse connection to the neuron. So here let's talk about the architecture. This one should be done before we can use any tool. So let me explain it. So here is the logical architecture. We arrange our chip into a network on chip. So you see the network on chip, and each element is a neuron synaptic core, and they are connected via a neuron network on chip architecture. And for each neuron synaptic, we have the neuron core like this. And each cores contain 256 neurons connected with 256 axons in a 2D network on chip. So here's the architecture. And here's the way that the whole network on chip works. So if a SPI need to be transferred from one core to another core, then a package will be formulated and transferred via the router to a core. And inside a core, the packet will be processed to get a SPI and do everything that I explained in the previous slides. Okay, so here's the way it done. So you see that a package, a SPI going into a scheduler, and then the scheduler will put the SPI via the synapse connection matrix, and then go into neuron core. However, this one is very complicated in order to implement in a chip. It's too complicated. So we need a physical architecture. So here the physical architecture, it is a near memory computing, a new kind. So you see that here we arrange the whole synaptic cores as a memory. And inside the memory, we have some computing element, which is a neuron block. So, and the whole core will interface with the bus. Here we use the wishbone bus. So in order to this work, for the logical operation, a CPU will be connected to this, and will issue the read and write command to the memory, because this one is considered as a memory. So the CPU will issue write and read command to that, and then after that, based on the command, the write read command, the whole system will work as we described. So here's the architecture that, of course, we need to do by hand manually. And of course, the architecture cannot done automatically. But then after having this architecture, we can do everything else, coding, RTL coding, by using AI, ChatGPT. So let's talk about AI-based design flow. So here's a normal IC design methodology. So we see that at the beginning, we we did the problem statement that I show you, and then we do the specification, and then we have the design concept, and then we have top level design, system architecture, and we have pseudo code. So all of these things we done as I show you manually, of course. And then after that, we need to write the RTL code, the Verilog code, and we need to verify it. Also, because this one has the SoC, we need to develop the firmware using C language. And then after that, we can integrate them. We have the user RTL design, and we integrate them into a hardware software system that can be co-simulated. So in this step, we can use ChatGPT. We can use OpenAI to develop everything. So the ChatGPT will help us to write RTL, HDL code, and then we need to feedback the ChatGPT with our feedback. Then it regenerates the code in an iterative way. And also the ChatGPT help us to generate a test band to test the code, the unit code. So here's the thing that we leverage the AI code. And after that, we after having the RTL designs, we can synthesize it using an open tool, which is OpenLane, to get a GDS tool, which can be fabricated. Okay, so here is some code that's generated by ChatGPT. So what we do, the ChatGPT can design the small modules, do the integration, and do the wrappers for the HDL. Then we need to review the RTL and create the simple test band with the help of ChatGPT. We can also generate the C code for the RISC-V that control the hardware. We can also generate the environment for testing. But of course, we need the HDL simulator to verify the generated code and give the ChatGPT the feedback. So here's some extraction from the chat. For example, we give some prompt, and then the ChatGPT can generate the Verilog module. And of course, we need to iteratively feedback to the tool, and the simulation tool is used intensively. And we need to give very detailed feedback. For example, here we see some potential overflow, and then we give feedback. And especially, we need to do multiple chat sections. It cannot be used in a huge chat section. We need to split it into several modules, and each module will generate by one section. Be generated by one section. And also here is a hardware software validation environment, which is also generated with the help of ChatGPT. So of course, this design is already done manually, but after having this design, we can use ChatGPT to generate the code to verify. So you see that here, we have a C code which generated by ChatGPT, and then we have the design under test, which of course generated by ChatGPT, and everything will be integrated together using ChatGPT. And then after that, we can run the simulation. Yeah. For the RTL synthesis, we use open framework, OpenLane, open road. Everything will be, after having the RTL design, we can run through the OpenLane design flow using the PDK Skywater 130 nanometer, and we have a full digital synthesis flow. And then after that, we have GDS2 files that is ready to integrate it into the SoC. So of course, only the design, our design is not enough to fabricate a chip. We still need the RISC-V. We still need to sign off the whole chip in order to fabricate it. And then this also take a lot of time if you do it manually. So here we leverage an open source SoC, which is RISC-V based, and it's totally open. It's carved. Here you can see that it's a Caravelle framework. And in the Caravelle framework, we have the RISC-V SoC core, which is already signed up physical layer, physical implementation. And then we integrate our core, our SNN accelerator here in the user IP design. So in this area, we have around 9 mm square to fabricate, to put our design into that. So here is we call it user project wrapper, and it is connected with the core, the SoC core via the wishbone. It is the reason why we have our SNN interface with the core using wishbone bus. So and then by leveraging this one, we don't need to care about clocking, DLL, RAM, and I/O interface. Everything is done already, has been done already. So and here's the result. So we synthesize it, and the die area is around 7.5 mm square. Our design can reach the clock of 40 megahertz, which then the throughput to processing the image is around 1,000 frames per second. And the power consumption is quite small. It's 0.8 nanowatt. And the most important thing we want to point out here is we need 60 man days to design the chip. So it's quite impressive as before. In order to design such chip, we need many more man days. And then we won the first place in the e-fabless competition challenges. It's AI-based challenges. So what have we can sum up? So we have developed a parallel network on chip SPI neural net architecture, which contain both hardware and software. So it's co-design. It's a near memory hardware implementation computing. It is hardware software co-design, and we use RISC-V-based SoC framework with an open source EDA tool. But the challenges that we face is if we increase the size and the complexity of the design more than that, then OpenLAN will got the problem. It's run forever. It's very slow. So I think the open source EDA tools still need a long way to improve in order to serve a commercial purpose. Of course, for research purpose, it's work good. And also because we use open AI, we use OpenAI, then the privacy and the IP problem can be need to be considered if we want to commercialize the IP. Of course, this one is for research purpose, and everything will be open. So since there's nothing happen. But of course, if you want to commercialize your works, then you need to rethink about that, or you need a private large language model other than ChatGPT. Okay, so thank you for your listening. If you have any questions, then you are welcome.
Is it still in the project or do you have any working?
First prize, then the chip will be come to us in this April, and then after that we can do some demo on the chip. Yeah.
So it is interesting that you create neural network using hardware.
Yes, exactly. Yeah.
So do you ever thought about the chip for analog neural network?
Um, I don't know whether the IBM or the Intel Loihi is analog based, but of course for publication we have seen based.
Means this chip will contain 4 bits, and the weight is put on the 4 bits inside
Yes,
the bit.
yeah, yes, of course, yeah. It's a computing memory, but many people believe that analog is a little bit behind digital because of process variant PVT. You mean, you know, and also it's not easy, and it needs a lot of DAC and ADC to convert from the bit to the voltage. Yeah,
ADC,
yeah, so ADC.
the latency.
Yeah, the latency will be large. Yeah,
So it is considered faster than the analog one.
yeah, yeah. Yeah, of course we need to. There's still two direction. Yeah. Okay.
Còn mà nào câu hỏi gì nữa cho speaker không ạ? Is there any questions for speakers?
Maybe last question.
Yeah.
What's the direct or the good purpose of this design?
Yeah. So you mean the advantage?
Yeah,
The application.
The direct purpose of this project.
The direction.
The direct the purpose.
I don't quite. You mean the throughput?
Purpose.
Purpose. Yeah. Okay. Okay. Yeah. Okay. So this one is a new kind of neural network. It's a spy neural net. So it's good for streaming data. Yeah. For example, if you have some data from the sensors, ECG sensor, for example, or racial sensor, then it will be very good for that. Of course, it cannot compete to CNN in image processing, because now CNN is very good at image processing, but this one will be good for that. So that kind of data, the data from the data. Recently, now we use we use one small RISC-V for a network consists of the 5 cores. Each core has 256 neurons, so it's around 1,000 neurons to control by one RISC-V. But we believe that we can increase the number of core. Yeah, yeah, yeah. Okay, thank you.
Another one. I'm just realizing we have already fuzzy logic, right?
Excuse me?
Fuzzy chip. Fuzzy.
Fuzzies. I haven't heard about any fuzzy chip.
Something like technology to put the result of the AI into the chip, and we respond based on the input to the output in fuzzy.
Fuzzy logic, you mean? Yeah.
It is comparable to this approach.
We haven't do any comparison with fuzzy. Yeah.
Because it is same chip to chip
Yeah.
approach.
Yeah. Not yet. We haven't done it. Yeah.
Thank you.
Thank you too. Okay. So again, thank you for your listening.
Wow, thank you so much for your sharing. Và để tóm gọn lại một chút thì là mình muốn giải thích một chút bằng tiếng Việt dành cho các bạn sinh viên đang ngồi đây, thì là bài của diễn giả vừa rồi thì sẽ nói về chủ yếu về cách tiếp cận để thiết kế cái bộ tăng tốc mạng neuron tăng đột biến bằng cách sử dụng những cái công nghệ AI nguồn mở để có thể ứng dụng vào trong những cái ờ, tức là những cái AI nguồn mở đấy sẽ được tích hợp ở trên cái hệ thống chip SoC và khung mở dựa trên cái RISC-V. Thì đó là những cái gì mà thầy muốn truyền đạt đến cho mọi người.
Hello, everyone. Good afternoon, I think. Okay, yeah, it's afternoon. Thank you so much for joining my talk. So today we'll be seeing how you can leverage blockchain to improve the security in OTA firmware update infrastructure. So let's begin. I'm Swapnil Shinde, and also I've been part of various open source programs like Google Summer of Code. I've been part of OWASP, where I was working with private blockchains. So OWASP is actually security related. So we were improving security using in blockchains. So cool. Okay, so let's start. So there are two types of updates in how you can update your IoT. So first one is, sorry, okay. Yeah, so first one is your wired, using wired method. So here you connect your IoT device using a physical link, which is your USB in case of this, and in case of Arduino, it's some type of cable. I don't remember that. Okay, so this is the most safest way because you're directly physically connecting to the IoT device. But there's another way. This way is not that practical because obviously in production environment you won't be like connecting to your car and then updating that firmware. The second way is over the air update, which is most widely used here. Like you have a centralized OEM server and then you push the update like the vendor. Hello. Okay, so the vendor pushes that update wirelessly and your IoT device will pull that update from the centralized server. But since it's wireless, so and also a centralized server is being used, it is not that secure. And now we'll see how we can improve the security of this system. Okay. So yeah, so these are the problems with OTA updates. The first one is firmware blues, in which like the attackers try to push malicious code into the IoT device, and the malicious update will be like the IoT device will behave maliciously, obviously. And the second one is DDoS attack, in which the attackers like sniffs in between and then like flushes your device with random packets, and your device will get into the boot loop. Third one is servers under siege, and obviously it's similar to man in the middle attack. So okay, yeah, so let's see some stats. Currently, there are 27 billion active devices, IoT devices connected, and it's according to 2017 report, and it will gonna rise up to 125 billion. So you can see it's almost like 5 times. Uh, you can see there also consumer sector is the largest one in which IoT devices are used, and you don't want your users to like get infected. Your users IoT device to get infected with malicious updates. So here are like the firmware blues attack that I told you before. 77% increase, like DDoS 60% increased. So here, let's see. Okay, so now let's understand how OTA works over the update technology, over the air update technology. So the first one is you have your source file, C source file, in which your firmware is written. Then you compile it to object files using a compiler, and then you link it using a linker to a binary file. And then when you have a binary file, you upload this binary file to your centralized OEM server. And then the IoT device, which you can see at the bottom, that pulls the update from the centralized server, pulls the update as well as the hash, and then it recalculates the hash. We can see it this in the next slides also. So you can see here, first vendor service pushes the update binary file to the server through a HTTP request, and you get a HTTP response back. After this, the vendor service creates an MQTT call to the IoT device. So you can see here, after that, the IoT device will know that, okay, there is a new update here. And now you have to update update to the latest version. So from here, the IoT device will pull the latest binary file, as well as it will pull the hash of that binary file to validate if it is if it is not malicious. So here you can see in the instructions, you can see it recalculates the hash by hashing the binary file, and then compare it to the hash that it got from the centralized server, right? Then if it is okay, then it like updates to the newer version, or it just roll back to the old version. So yeah, so there are a few challenges in this. So first one is man in the middle attack. So when you are sending both the hash as well as the binary file from the same server, you can make it different also, but the problem is any attacker can sniff in between. Like you have your Wi-Fi and you have your IoT device connected to that Wi-Fi. Then anyone can sniff in between, read that packets, make changes to that packets, or like change whole binary file, and then your IoT device will receive a different update. But it will not know that, okay, this is not a real the actual update that it got from the centralized server. Uh, the second one is DDoS attack. Same in this case, flushes with random packets, and your device will go into a boot loop. Okay. And the third and last one is, which is the most severe one, is when your OEM server got compromised. So in this case, anyone can pushes like malicious update, and it will directly go to your IoT device and it will infect the IoT device, right? Okay, so the need of blockchain is the problem is with that server and the vendor organization part. So here the server is centralized, and we can improve the security using blockchain. So you can see when you push the update, the IoT device will pull it and send a diagnostic report back to the server, right? So we can replace it with the blockchain. It totally depends if you want to replace whole infrastructure, or like whole server, or like run the blockchain parallel to the server to save the hash of the binary file in the transactions of the blockchain. Okay, so this is how it looks when you replace it with the blockchain. What you can do is the binary file was stored in server, right? But and also the hash of that binary file. What you can do is you can move it to blockchain into a transaction, and then you can send instead of sending a hash of that binary file, you can send this transaction hash of the block in the blockchain. So after, like you can see when the this installation is happening, when the IoT device calculates the hash, it can query the blockchain through some intermediary HTTP server, can query the blockchain and get a Boolean value, suppose true or false, and based on that, uh, it can either update or deny the update, right? So this is the architecture. I'll show more architecture ahead in the presentation. Okay, so for those who don't know about like what is blockchain, blockchain is basically a piece of a linked list or pieces of blocks that are connected with each other, and each block stores some transaction or some data, and each block is connected to its previous block through the through the hash of that previous block, right? Okay, so to manage this blockchain, there comes a concept of nodes. So this node is basically your Bitcoin node, your Ethereum node. So node is basically a software in which your whole networking layer, whole consensus mechanism, all these things are written, and how to manage that blockchain, all that code is written in this node. And this is actually a single node. Anyone can attack this node and change any of the block. It would be not that easy to change one block, because if you want to change one block, you have to recalculate nonce for all the blocks, which is very hard. But when you connect it to the network, now you have a network of nodes. So here if somebody tries to attack one node and maybe two nodes and change something in both of the nodes, so what happens here is consensus mechanism won't allow to do this, because you are like directly changing into the node, and the other node has already those update blocks already like attached to the whole chain. So you have to hack the whole node or whole chain in order to change the update. So this is very hard, and that's why you can replace your server, like centralized server, with whole network of chain, sorry, whole network of nodes. Okay, so these are the benefits if you use it. First one is your immutable ledger, in which you can store your update or your transaction hash, depends on the blockchain you are using. Okay, and second thing is smart contract reinforcement. So smart contract basically is a piece of code that is deployed on blockchain. So and it is run on the blockchain only. So no one has the authority to claim that okay, this is my code and I will only run it. If it is on the chain, then whole network owns it. Okay, so you can write your logic of update, whole update procedure, whole update flow in this smart contract, and you can deploy it on the chain, and it will run automatically based on the conditions when it is when they are met. Third thing is decentralized security, obviously, that I told before. This is a network, and you have to gain majority of the network power in order to change anything into the network. Okay, so now let's see the implementations, how you can implement this. So there are two blockchains you can use, two types of blockchain you can use. First one is your private blockchain, and second one is your public blockchain. So in private blockchain, obviously your network will be private. If you're a company, you don't want your update to get pushed into a public infrastructure, then obviously you will need a private blockchain. Second thing, obviously, public blockchain like Ethereum. So Ethereum, Bitcoin is a public blockchain. If you do anything, a whole world can see it easily, right? So this Ethereum is basically public blockchain, but Ethereum has a tool called Geth. You can, which is basically Ethereum node. You can fork that and create your own blockchain, own private blockchain also, using a proof of authority consensus mechanism. Either you can use Ethereum or you can use Hyperledger Fabric, which is maintained by Hyperledger Foundation in collaboration with Linux Foundation. So this blockchain is for industry corporate users, and this is basically a blockchain framework. You can use this to create your own chain, launch your own infrastructure. Third one is Polkadot Substrate. So it's similar to Hyperledger Fabric, but it is much more customizable. It is created by Polkadot Foundation, and it is written in Rust. So you can easily fork it. You can add smart contracts features to it. You can change whole logic of the chain. You can do anything if you have this Polkadot Substrate framework code, right? Uh, Okay, so basically, we actually I read a research paper on this. That's why I got this idea about this. So there were like 4 or 5 research paper published about this topic. I read them and I thought, okay, let's build this. They also built this and tested it. So in a hackathon, we actually built this using Avalanche Hyper SDK. It's similar to Polkadot Substrate. It's also a framework. You can use it to create your own chains, same customizability, but Avalanche is very much faster than Polkadot Substrate. So your updates will be pushed very quickly. It's like 65,000 transaction per second. As compared to Ethereum, it would be like 15 blocks in half an hour, or I guess one block half an hour. I'm not sure about that, but yeah. So now here you can see this is the vendor service, that is our blockchain part, and this is our IoT device, right? So what vendor do is vendor pushes an update to the Hyper VM, which is a virtual machine, basically a node in Hyperledger, sorry, in this our Avalanche subnet network. So when the update is pushed to that network, the network, what it do is it pulls that binary file, right? And then it uploads it to IPFS. So IPFS basically a blockchain-based decentralized storage, right? So it stores your binary file there, and now no one can change it when it's stored in the IPFS, right? And after that, it gets the URL and map that URL into the blockchain. That okay, this is the update for this device, and this like the parameters you passed during the HTTP request phase. And after this, all the URL and the info about the update will be stored in the blockchain. And after this, you can create an MQTT call for the IoT device. And now the IoT device will know that, okay, this is the update, new update, and I should pull it. But in this case, you will just give a transaction hash that, okay, this is the new sorry, this is the new update, you have to pull this update, right? In the previous case, you have to give whole binary file and the transaction hash, but in this case you will just give the transaction hash, and the IoT device will just query the HTTP node exposed from the hyper VM, one node, or it can query multiple nodes also, and then pull the binary file from the IPFS, right? And also pull the hash of that binary file from the blockchain. And now this IoT device will have both the things, and it can easily like recalculate the hash and check if it is matching, and perform the update, right? Okay, so yeah, perform the update. Cool. So this is whole infrastructure. We also have like block explorer, which is basically you can see the transaction or the updates that you pushed. You can see all of that in this snow trace block explorer. So all this infrastructure, we tested it on our local host. This is for a hackathon. We won first prize in that. And okay, so yeah, so this is basically the smart contract reinforcement here. So what you can do is for verifying the hash of the like uh, hash of the binary, what you can do is you can calculate the hash, and then you get the hash, then you can query the blockchain, okay, this is the hash what I got for this transaction ID, right? And use in that verify function, and this is whole smart contract, this is all smart contract deployed on the chain. And then the chain will, this contract will calculate, okay, if the hash matches, and then it will just send a boolean value back to our IoT device, and it will just update the system, right? Okay. Okay, so now let's see what are the resilience against these attacks that I mentioned you before. So this I took from a research paper, some of the research papers, because we actually tried it on our system and we didn't got any expected result, because we developed that in like 2 or 3 days. So, but we still managed to find some research paper and the analysis they did. So here, what they did was for denial of service, they that the OTA library, the over the update over the air update library for ESP8266 was like vulnerable for this DDoS attack. So they created a script and pushed a new update. Basically, new update means random data to the node. So it was not update; it was like random data, and they DDoSed it, and they got after some time they got this timeout update rejected error. So here because they got this because the ESP32 tried to like get that data and calculate the firmware hash, and then it queried the blockchain. And when it queried the blockchain replied, okay, this is not a valid firmware update that our company sent to this device. So that's why it got like resistance from this DDoS attack. The second one was like man in the middle attack. So obviously spoofing in between the network and then pushing the update to like the IoT device. So here in this case also it like started the verification. You can see verifying with blockchain. So it sent the calculated binary hash to the blockchain, and then the blockchain obviously replied false, and then whole verification phase like you can see failed and aborted and rebooted back to its previous uh, firmware. Okay, so so I think we have time. So I cannot show you the actual demonstration because it's very too long. But I recorded a video in another conference, so I'll quickly show that to you. Okay, so now I'll demonstrate. Okay. be uploaded to your IPFS via the updates CLI only. So if I go here, you can see this hyper OTA. This library we built using elegant OTA, which is this hyper OTA is basically fork of elegant OTA, and we have changed some code to call our chain and then get the validation of that hash, binary hash. And we will upload this into our ESP32, which is here. Currently, it is connected by like a wired connection, but this Wi-Fi is connected to my like home router because like we connected this Wi-Fi because we wanted to see the serial outputs of whether the update is happening or not. So okay, now I'll upload the initial code to my ESP32. Okay, so here I updated like initialize my IoT device with the new firmware, and after this, what I'll do, I'll push the firmware from the blockchain. So you can see after this. Okay, so it will really sorry for that. Wait. So now I'll this data will. Okay, so here you can see the update is done, and okay, rest is here. Here you can see this. Okay. So okay, the response is our transaction ID of this data. So we can just call the chain using this transaction ID, and we get this data back. Now we'll create an update to this transaction ID, so that like this transaction ID is basically pointing towards our project, and our single project will have multiple updates for that. So that's why we are pointing it using our transaction ID, our device name, and our version name with the binary file. So what we'll do is we'll just change something here. We'll change. Okay, we'll change this dot to plus, which means these consecutive dots will be now received as plus. We will compile it again, and then what I'll do is delete this pipe and copy it from the build. So okay, the build is successful. We'll copy it and then paste it here. So now the blockchain. First, the binary file will be uploaded to decentralized storage, which is IPFS, and then the URL of that will binary file will be mapped into a chain data being happening. Okay, so here I push the binary file into the blockchain, and after this, you can see I pulled the update. You can see just a HTTP call, and you can see the data is there stored into the blockchain, and then these are the like the project library a code. You can just go here or like just connect with me. I'll provide this. After this, I push the firmware for this device IP, and you can see after this. Now, if we see here, you can see the update is happening, and the vendor service to the chain to get the valid transaction, the valid hash of this firmware update. Valid, and so you can see the consecutive dots were replaced with the plus. So the firmware is actually updated through the blockchain, right? So yeah, so this was the demonstration, and yeah, so these are the sources. You can refer to this if you these papers if you want more knowledge about this. And thank you so much. I hope you learned something awesome, and hope you learned something amazing. Thank you so much. Do you guys have any question you can ask?
Is there any questions for the speakers?
Okay. Yeah, sure.
Related to the smart contracts, but maybe we confused about we don't know exactly smart contracts, and how we can try to avoid dispute settlement and we try to sign smart contracts in our coding.
Okay. Sorry. Actually, I
You
didn't.
understand it?
No, actually, I
Not yet?
didn't.
Okay.
Yeah, sure.
Okay, thank you very much for your very clear presentation. My question related to the smart contracts. When we try to do some international trading transaction, but we try to keep the obligation and rights about both sides. But maybe sometimes they can raise some dispute between such things. But how we can solve dispute? Okay, if we sign smart contract, whether or not we have opportunity to change the smart contracts. Okay. Mm.
Okay. Yeah. So I think dispute won't happen. Are you talking about like if we push the update into the public blockchain, then others might see it and cause a dispute like that? Uh, yeah. Absolutely. Yeah. You can change it. Yeah. If you're using Polkadot, also you can add your own smart contract implementation on how the smart contract behaves. Yeah. 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 You can change it absolutely with. Oh, you are talking about that. Okay, yeah. If you upload a smart contract to the blockchain, then you cannot change it. If you want to update the smart contract, then you can create a new smart contract and push it to the blockchain. Then you have the newer version, but you cannot change the previous smart contract. Now you have the new hash of that smart contract, and you have to use that in your infrastructure. There is also a problem there. You have to, if there is some change in the code, you have to do that. Thank you so. Thank you so much for attending my talk.
All right, thank you so much for just sharing. And I know that this will be a little bit hard to understand for all the students here. Vậy nên thì là, so I want to retranslate it into Vietnamese for some students here. Vậy thì là trong cái bài nói của speaker Shinde vừa rồi thì anh Shinde có muốn đề cập với mọi người là thì như mọi người đã biết thì trên thế giới hiện nay thì có 15,14 tỷ các thiết bị được kết nối với nhau, thì là chúng ta cần phải đảm bảo được rằng là những cái việc cập nhật chương trình đấy, những cái việc cập nhật ấy thì rất là quan trọng. Thì trong cái buổi này thì là cái anh speaker đang muốn mang đến cho mọi người là cái công nghệ blockchain, tức là cái công nghệ khóa chuỗi ạ, để cách mạng hóa cái việc phân phối các chương trình cơ sở và mang lại những cái bảo mật cũng như là những cái sự niềm tin vững chắc hơn trong các chương trình mà mình sẽ lập trình. Thì đi sâu hơn vào nó thì chúng ta sẽ thấy được rằng là anh đã nói về một số cái lỗ hổng trong những bản cập nhật OTA truyền thống. Ngoài ra thì là cách hoạt động của các khóa chuỗi hay là cách hoạt động của các blockchain. Tiếp theo là chúng ta sẽ tìm hiểu về các khung nguồn mở, tức là xây dựng hệ thống cập nhật an toàn cho những cái hệ thống như vậy. Tiếp theo là sẽ là khuôn mẫu đang hoạt động, cũng như là nếu mà mọi người có bất kỳ thắc mắc hay câu hỏi nào liên quan đến công nghệ khóa chuỗi hay blockchain thì có thể là contact với cả anh Shinde ở đây thông qua có vẻ như là anh đã tắt rồi ạ. Thì đấy là có thể liên hệ với anh Shinde thông qua chương trình FOSSASIA lần này. So this is the end of the second sessions of our talk today. Next, we will have a workshop which will begin in next 3 minutes. Please stay tuned at the main hall at this room for the workshop. And the next workshop will call "How to Create Magic Wand in Harry Potter using TinyMLs and edge impers." Please stay tuned, everyone. Tiếp theo thì chúng ta sẽ được tìm hiểu về cái làm thế nào để tạo ra một cái cây gậy phép thuật trong Harry Potter, sử dụng cái công nghệ Shinde cũng như là xung lực cạnh, thì sẽ được trình bày qua bởi anh Salman Faris.
Hello, hi. With you Could you please open your laptop? We will distribute the hardware with you, okay? Yeah. Please open your laptop. Everybody should have a laptop computer with you, and you should install Arduino IDE. I will share the software in my pen drive so you can install in your computer. Then you also need to install some other tools, okay? Cool. And this is a asynchronous workshop, okay? Could you please open this link for me? The link.megagram.com/magicvan. Please open the link. All the instructions step by step actually documented in the link. So you can go with your own pace. You don't need to wait for me to explain the steps. You can go with your own pace and everything. We will distribute the hardware for you. Like we have the hardware and the cables and everything with us. So we will distribute you when we start the workshop, and you can use your own pace. Okay? Is it clear? You understand? Okay. And if I am speaking too much fast, or if you don't understand, please raise your hand. Okay? Hello? Okay? Okay, cool. Cool. Okay. Is it all open the link? Link is accessible? Okay, awesome. We can open the link, right? link.makegram.com/magicvan. That's your link. I think if you have a laptop, you can open your laptop. Do you have a laptop? Okay. Okay. If you want to sit there, you can sit somewhere. Like it should be some cable and everything. So it will be better you sit somewhere. If you're comfortable, yeah. They have a seat from that side. Yeah. Okay. So this is a slide, right? Okay. So today's topic is about like how to make a magic wand. So the magic wand is based on tiny machine learning. So how many people are familiar with the term machine learning? Machine learning. Okay, no problem, no problem. Okay, okay, cool, good. So yeah, right. Okay. So before starting tiny machine learning, we need to understand what is machine learning. Okay, you might hear the word, right? AI, ML, deep learning, etc. So what is the difference? What is the difference between AI, ML, and deep learning? Okay, so the AI means artificial intelligence, means we are trying to mimic human intelligence using computers. Okay, so like it's like a similar to like we are trying to make similar intelligence that with the computers. That is AI. That's called AI. There is two type of AI. Anyone know? Two type of AI: artificial general intelligence and artificial narrow intelligence. Okay, so artificial general intelligence means that's actually very much similar to the human brain. Second one is artificial narrow intelligence. Artificial narrow intelligence, like it can do small tasks. That's can be the chat GPT. That's artificial narrow intelligence, ANI. Okay, and AGI, this artificial general intelligence, that can do so many things that can might kill humans also. Okay, that's AGI. Okay, cool. And next part is machine learning. What is machine learning? Machine learning is a subset of AI. Okay, that means like it can learn from data. That is machine learning. Okay, so you actually come to school, right? For what? You are learning new subjects. So you are actually trying to read books, you are like watching lecture, etc. You are trying to learn. So that part actually called machine learning. So it will read the data, then learn from the data. Okay, so what is about deep learning? Deep learning means the algorithm that used by machine learning. Different kind of algorithm. That actually the like KNN, that's an algorithm. So many algorithms are actually there. So deep learning is an algorithm, and machine learning, using the algorithm we will try to learn. Okay, artificial intelligence means using the knowledge to actually act something, to do something. That actually AI. Got it? Now you got now you understand what is the difference between AI, ML, and DL. Cool? All great? I need your response. Yes? Yes? Okay, cool. Okay. So, okay. So you might have questions. What is the difference between traditional programming and like machine learning? Okay. So how many people do code, do program like C++, HTML or anything like that? Okay, yeah. What kind of language you use? Which language?
I often read, I often writing in C and assembly.
C and assembly. Oh, that's great. Okay. So there are so many languages, right? C, C++, Java, like Python, so many languages there. So what is the difference between normal program language and machine learning? Okay, let's see. So in normal program language, we have an input and there will be some algorithm. Okay. And there should be an output, right? So we actually creating the algorithm and we give the input. That's clear, right? Okay. So when it comes to the machine learning, instead of we are creating the algorithm, computer will generate the algorithm for us. Okay. So that's a two part. So first part is called like creating the model or training the data. So from there, we actually give the input plus output. We will give input plus output, then we will get a algorithm. This is the algorithm. We will get the algorithm. Okay, this is the first step. This is called training the data. The second part is inferencing the data. For that, we actually, that's very much similar to the traditional program. We give the input and to use the algorithm here, trained model, and we will get a result as a confidence. Machine learning is all about like probability or statistics. So there will be confidence about like how much percentage is confidence in 100. Okay? Good? Okay, cool. Because it's a very fundamental thing, so you should understand this one to get into the workshop. That's why. Okay. So next one, how machines are actually like understand things. So I think previous session there was a professor mentioning about how human brains are working, right? Similar to that, how machines are learning. So this is how machines learn. Suppose you have a small baby with you. Okay, suppose you have your kid or your niece with you. How do you like teach like his her about a dog or cat? How do you teach? How do you teach it? You show them, right? This is a cat and this is a cat. That's how you show that like it's a difference between cat and dog, right? So that what happens is like the kid will understand that the kid in the kid's brain there is something called neurons. Neurons is small memories. From there, the kid try to store the data different side, right? So it might be sound from the cat like meow meow. That's a cat. Bow bow bow. That's a dog. The kid will understand. Okay, that's a dog or that's a cat, something like that. So what happened is like what happens is like when baby like the parent we will teach them kid look this is a dog this is a cat then in kid brain what happens is there is some kind of things called neuron development. Okay, the later the kid will try to like using the neurons to understand okay this is a dog and this is a cat. Okay, this is how humans are learning. So far we understand that's we so far we understand from different kind of research. This is okay, right? Good. Okay. Next, how machines are learning. So instead of the baby, I replace the computer. That's all. Okay. Instead of teaching, we are using training. So like you can see here, we have a biological neuron that we have. This one is called artificial neuron network (ANN). So what happened here, like if you want to teach a computer the difference between a dog and cat, we need to show them. We need to show the computer, hey, this is a dog, this is a cat. Then computer will automatically try to understand what are the difference between a dog and cat. The dog is a big one, the cat is a small one. Dog can do like bow 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 like that, and cat can do like meow meow something like that, right? That's how like the computer will learn. The later point, the computer can understand which is a dog, which is a like a cat, with the neurons there that actually already developed. You understand now how computer learn, right? This is a basic concept how computers actually using like ANN to understand things. This is a part of machine learning. This is how machines are learn. So first we need to teach the machine will understand what's behind it. The machine that use the knowledge. Okay. 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 Great. Thanks for the feedbacks. Okay. What's happening? Yeah, okay, cool. So yeah. So normally, let me make it big. So all the slides are also available in the documentation, so you can watch, rewatch. So basically, to run machine learning, we need a big computer. We need powerful machines which have GPU, which have TPU, tensor processor unit, or graphic processor unit, etc. So in nearby, yep, okay, yeah, sure, that's better. So basically, in the past, we need a big computer to run machine learning in computers. Hello. Yeah, cool. So we need like big computers. It need at least like 60 to 30 GB models, teraflop of speed of like processing powers we need to run the machine learning. Okay. Yeah, cool. So we need like teraflop of speed of things, and we need GPU, TPU, FPGA, etc. The next one is like mobile ML. Mobile ML means we can run machine learning on mobile phone. How many people use Hey Siri, like Hey Google, etc. Right? That actually machine learning running on computers. Sorry, mobile phones. Okay. The next part is TinyML. TinyML means running machine learning on microcontrollers. So today what we are going to do is we are trying to run machine learning on this device. It's called Xiao. So we are running machine learning on this small device. Okay. So we might already use machine learning. How many people use smartwatches? Smartwatches, right? So it can track your steps. That actually machine learning. It try to recognize you are walking or a step, you are like walking or sleeping or standing, etc. It can recognize that actually machine learning. So that's about TinyML. So in the past, it's all about like Internet of Things. So we connect device with the internet. Like we can connect internet to the chair to whether to check if the person is sitting or not, etc. Like that. But right now, it's all about intelligent on things. The device can analyze the data itself. You can analyze if how many times a person is sitting in the chair. So if you want to give some another notification, you can do some vital information check, etc. So it's all about like using machine learning on the edge, because like we can save so many bandwidth. We don't need to send all the data to the cloud. We can process like from itself, edge itself, then do the only the processing data we can send it to the cloud actually. So what is TinyML? So TinyML is actually combination of machine learning and embedded systems. Okay, it's a combination of machine learning and embedded systems. And right, I have a few slides like it's a fastest growing field of machine learning right now. So if you are a student, it's the best way to, you can try to learn it because it's the fastest way of growing field. And we have so many algorithm, hardware, softwares, etc. And it to do on-device sensor analytics because all the things actually run inside the small chip. So that's cool. And always so ML and low power consumption. Yep. The main benefits of HML is like innovation, privacy, and power, cost, and like reliability and latency. Because privacy is very important. You actually own your own data. You don't need to send the data to the cloud. Okay, for the TinyML. Okay, good. So this is one of the product that made by Adidas. How many people watch football? How many people watch football? Any football fans here? Okay, cool. Right. So you might know Adidas, right? Adidas is a company like those make very good in like sports accessories. So they make a device to monitor the players the styles, so they can understand how many times the player kick, what kind of kick they made, etc. We can do some things with the camera, but we'll get more information about the sensors, like how many, what kind of pass they do, what kind of dribbling they do, etc. So this is a product that actually released by Adidas using tiny machine learning. So, and one more thing is tiny machine learning is not for all the things. It's actually only fit for a small set of things that actually we need ultra low power sensor devices. And if we can do it's unable to do like image processing, like a big quality, or we can do like a video analytics, but we can do so like a small like sensor analytics to the edge predictions. Okay, so let's get started to the workshop. Okay, So I think you might open this page, right? Okay. So that's about the introduction about TinyML. Hope you understand everything, right? All good? Good? Say yes. Yeah. Okay, thanks. So today we are going to make a magic wand. So this is an algorithm for the magic wand. Let me show you. So this is where we start. And this device have an IMU, accelerometer and gyroscope. Okay. So it will run some machine learning model. And if it's detect a gesture, it will send perform an action. Then like it will end. This is an algorithm. Okay. So this is our device. I'll show you the demo right now. Okay. This is our magic wand you will going to make. So just want to connect here first. Okay. So if I make a presentation, let me see if I can change the presentation. Very good. So I can actually move. See? So I can spell some magic. Something like that. So it will change. See? So it actually what happened is like it detects the gestures and try to do some machine learning on the edge and will send the data to the computer. So if I need to go back, I can like this, it will back. See? Okay, so we can try to make one our own. So the first step is you need to do is like we will distribute the device with you. Before that, you need to go these steps. First, you need to install the Arduino. Go to the website. Go to the website first, arduino.cc. Then you need to download the IDE. Please try to download the IDE first. First, try to install the Arduino IDE. Yeah, you already have? That's great. If you already have the Arduino IDE, then what you can do is like you can follow the second step. Introduce Xiao, this one step. Yeah, this one. Yep, good. So how many people already have Arduino? You can download and install Arduino. If you have a slow internet connection, I can give the USB for you. Okay, great. You already have Arduino. That's great. I think so many makers already here. Okay. The file?
So can I get the code via software?
Okay. Can you open this page? For the documentation, you can open this page like this page. Okay. For the documentation, please open this page. And please note, this is an hands-on workshop. There will be so many things going to wrong. Okay, it will be not work as supposed to do in the website. So we will try to debug. Okay. First, we are going to install the Arduino IDE. You got the link? No? Yep. Open the link, please. How's going here? Okay, cool. Now you already have the Arduino, right? So now you can go to the, this one. You can follow the guides. Yeah, you can follow the steps. What about you? Okay, cool. You already have the Arduino, right? No? Okay, you can start. That's good. What about you? You want to try make a magic wand? Can do together. Yeah, just open your computer. Yeah, try. Low power. You want a charger or something like that? No. Okay. So I'll just walk through here. Okay. So let me know once you have completed the Arduino installation. Okay. So once you've done Arduino, okay, not that one. It's automatically gone. Okay. So once you done Arduino, you can open the IDE like this one. Okay. First you need Arduino, then you follow the guide mentioned here, NR52840 cents. So this is the device we are using today. It's called Xiao. What? Xiao. Say Xiao. Xiao means in Mandarin means tiny. Okay, so it's tiny, right? Xiao. Okay, so it comes with a microphone plus an accelerometer. It comes with a microphone and accelerometer in tiny device. And it's also have a Bluetooth connectivity. Okay. So we are trying to run machine learning on this device. And the first step is you need to install Xiao NR52840 Sense on your Arduino IDE. That's the next step. Are you able to follow? Good. Okay, perfect. You already know ESP32, so you guys are trying. See? Are you following up? No. Okay. So you install Arduino? Ah, okay, good. If you want, you can use the Arduino IDE. Oh, okay. Good. Yeah, perfect. Installing the Sense, that's good. And what about you? How's going here? Okay, great. Did you install the NR52840? Oh, you're using PIO? Can you use Arduino IDE instead of PIO? Yep, that's one. You need to follow this one. Can you open the page? Yep, yep. Did you install this one? This board. Yeah. Yeah. Not that one. That's ESP32. We need the. Mm, you can copy this one. Copy that one. Then paste the board URL. Okay. Okay, then go to open the board manager. Yeah. Once it's done, you can open the board manager. Yeah, I think we can install. Yeah. These are the USB we have. After the workshop, you need to return the hardware to us. Okay. Please return to the hardware to us like after the workshop. So we also have the USB cables. Yep. So you need a computer. You need a computer. So after the workshop, you need to return the device to us. Yep. You got it? No, it will not work because it needs some inbuilt sensors. Yeah. You have a computer? You don't. Then you don't need it. So after the workshop, you need to return the device. Okay? Yeah. What happened? So you can open. It's a cable. Yeah. Just open it. So what happens inside? Like it's a Xiao. So you can open the cable to connect with it. Okay? So let me show you.
Thank you so much.
Okay. Cool. Okay. You already installing, right? It's done. Oh, perfect. Now you are installing this one. Okay. Good. Good. Great. So what about you? How's it going? Okay. Yeah. Take your time. Okay. So you're trying. You got an USB? No, right? If people need more USB cables, let us know. Okay. If anybody need USB cable, let us know. You can follow the guide. You can follow the guide like this one. It's how Bluetooth, but you can connect with the USB. So no, it will not show as a Bluetooth. Okay. Yep. Perfect. Okay. Let's do. Let me know like once we are done with the installation. Okay. Let me know when you are done with installation. You need a type C. Okay. You have any cables with you? The MacBook charger? No? Nothing. No worry. I'll give you one. Just a minute. Which one? Which one?
Is it on?
Actually, you need to use Arduino IDE. So if you open the Arduino, you can go to the tools. If you go to the port, you see this one. There will be. So first, you need to install the Xiao. Go to the website. Let me open. Did you open this one? The page?
I think this one.
This one?
Audio.
Nope. So you need to open. It's like you need to open that page. Workshop. Yeah. So we have some prizes, those who complete the project. Okay. So if you complete the project, you will get some goodies, some prizes. So try to complete as fast as fast. Yeah. It's a cable for you. Yep. Good. Blink. Okay, that's awesome. So one person is completed a Blink program. That's good. Nice, nice. Yeah, it's done. You are getting a Blink. Yeah, congratulations. Good. So we got a Blink. So once you are done with it, like what you need to do is like, let me show you. Go here and like sketchbook and like, let me go here. Yep, this one. You need this link, right? Yep. Magic Wand. link.makegram.com/magic wand. You don't need to wait for me. You can continue reading the guide and you can do like the session. You can continue. Okay, you got it? Okay, awesome. So the first step is we are going to make turn on the light of the shower. For that, I need to go like examples, basics, then blink. So I need to make sure that I selected the correct board from tools, board, and we need to select the NR50 to embed enabled boards to sense. Then port should be there once we connect the device. So yeah, once we connect the board, you can upload the code. Make sure that you have the port selected. Then upload. So what happened is like it will do the blink. There is a small LED inside, like a side of the board. It will turn on and turn off. So what's the first program when you do when learning programming? Hello world, right? You do hello world first, print hello world. But for electronics or embedded program, we do turning on, turning off, blink LED. That's actually the hello world for the electronics. So let's see if my LED is turning on. It's doing the compilation. So what happened is converting the C++ code to the binary format so that it can read. to do the compilation. It will take little bit more time because if it's the first time. Let's see. Compilation is done. After that, it will try to upload the code to my board. Let's see the LED will turn on or not. Okay, it's uploading. There should be some issues with you while doing the upload. We need to make sure that it's have the correct port, to have the correct baud rate, etc. Okay, awesome. So now you see the red light, right? The red light is blinking. That means the program is uploaded successfully. Okay, cool. So how many are done with the upload? Having any issues? Yeah, I can work. Sorry? Okay, yeah. It's okay. It will take, yeah, it's done, I think. Cool. Now you can try to upload the Blink example and see. Try to complete, okay? You will get some goods. Yeah, sure. You want to try?
Yeah, I got some work and then I just like.
Okay, if you want to try, we'll give you the board. Yeah, you can try. Yeah, sure. No problem. We need to use NR52 and the sense one. Yeah. Then you can use any Blink example. This one is a complex one, I think. Change. You can like examples. That's Blink, right? Okay. Yeah. Okay, great. Sorry. Okay, like how many people are complete the Blink part? Yeah, 1, 2, 3, 4. Okay, 4 people. That's great. So you're done with the Blink part. Okay, now installing the CLI. Okay, perfect. Oh, you have some issues. Okay, did you install the Python 3 and Node.js? Okay, then what's the error we are getting? Oh, okay. You need to install this one also. Small one. That's an issue with the Windows. Okay. So if you have an issue, don't problem. We can go to the next steps. Okay. What about you?
To connect with my
Okay. You want to connect? You already installed the board. Okay. Let me open tools board. Okay. You need to install the this one. You need to go here. Okay. To go here and yeah, copy this one. Yeah, just copy that. Yeah. What about you? How's it going? Okay, installing. It's okay. Done. Okay, downloading file. Okay, this is like a time-consuming part. Once we're done with it, it will be easy. Okay. Okay, it will take some time, but it's okay. Let me or Alan know if you have any issues. We will try to fix it. Okay. Yeah, no problem. Meanwhile, it's installing. You can read the blogs, the project presentation. You can see. Okay, install the Windows. Sorry, the Node.js. Okay, cool. You have issues?
yes, I know it.
Okay, cool, great. What about you? Going well? Okay, cool. Okay. Okay. So, like, if you're done with the Blink example, you can try to run another program. Can you open this one? You can go and sorry, not this one. Where that page? Okay. Like, how many people are done with the blink part? Okay, so once you've done with the blink part, you can go here and do this part. Like step 2. Step 2 means fetch accelerometer data from Xiao. That's a step 2. Okay. So what you need to do is like just click here. Can you click here? The whole code will copy. Just click here. Then whole code will copy. Then you can go here and like paste. That's all. Then you can upload. That's all. It will automatically do the like compilation and it will upload. Okay. You might get some error like you don't have the library or something like that. In that situation, you can like copy this LSMD like LSM6DS3, then go to here, then like paste here. So you can download the library for that. It's called Seed Arduino library. You can install that if you get any errors. So it's doing the compilation. Okay. You're getting any error? Ah, okay, yeah, that's error. So you can go to the library. This one, you can enter the name LSM. Not that one. You need to choose the Seed Studio. Can you go down? Go down. Like, yeah, that's one.
Yes.
Yep, perfect. Yeah. Okay, cool. You can click install. So I think you will get an error, right? So you can install. Yeah, perfect. You're doing well. What about you? Yeah, it's okay. It's due to computer is slow. That's it's fine. Okay, once you're done installing that, and once you're done with uploading, what you can do is like you can open. There's a thing called a serial monitor. If you open this, you can see the XYZ acceleration. So see, the values will be changed. So it's an accelerometer inside the device. Okay, and if I go here, I can see the plotting values. So this is the XYZ axis values. This is the data. This is the raw data from accelerometer. We'll try to collect the data. We will try to collect the data and use machine learning to understand the data. Okay, later point. So for this is the raw data. You see. So this will be the up and down. This will left and right. If I don't do nothing like to like stable. See. You can detect all the vibrations from here. Okay. So this is the step 2. You want to try? You have a computer? Okay. So let me know if you're done with the step 2. Okay. Issues? Okay. Can you go to the tools? Tools, then port. Make sure that. Okay. That's fine. Can you disconnect and connect back? Let me see. Let me check. Okay. Okay. It's okay. That's fine. Let me see.
Maybe related to my window.
Hmm?
Maybe it's related to my window.
Yeah. Yes. Yep. Can you go to the port? Yep. Do you have another USB? You have another USB that side? Yeah, can you try? Because sometimes it will not detect in a proper USB. Yep. No. You done the blink part, right?
Yes.
Yep. So there's something wrong. What's happened here? Not yet. I think it's not. You can connect back here itself. So let me know. Like once you're done with the step 2. Okay. Yeah, done. Having issues? Do you install the library? Okay. Just a moment. Oh, your code is also not uploaded right yet. We need to use this one, embed. Okay. Then try, let's see. It's not connected yet, right? Can you close the ID and reopen it? Okay, then try.
select then your ports are not displayed. Try on another port.
Yeah, you have some issues with the port.
No, actually, it is not compiling. But it is not detecting how to compile. No, actually, it uploaded the blink sketch. That's why. Try it again. Na.
Did you install the library?
Yeah, I
Not this one. You need to use the Arduino one. That's why the issue.
Yeah, but one is this.
So not the Seed Studio one, not Arduino one.
Oh.
You can go below and choose. You can remove that one.
Don't you need to add the board as a
Yeah, I think you already added.
Oh, that is
Just below. Yeah, that's one. Okay, cool. Then it should be completed. It's a class difference. Okay, anybody completed the step 2? Step 2? You done? Oh, step 4. That's good. Yeah, you'll get the prize. All done? Still have issues? Okay. Okay, can you just move? So what I can do is I can give you an input. Okay. Try this board. Did you take me? Yup, yes. Yeah, so you got the data, right?
Yes.
Perfect. So we got one complete. Yeah.
Just live. Maybe we can install this live.
Okay, so I think you have an old Arduino. You can go to the library,
Yes.
include library.
Oh, I remember this.
Yeah, you need to go to manage library. So there's another window. So there you can enter the library name. So yep,
Okay.
here you can enter the name, then download. Make sure to download the seed library. Yep. Issue? Okay, let this one. Yep. So it's going. Okay, you might have some issues. Let me see. Tools. Shower. Have some boards. That's good. Port. Com. Okay. Let's upload. Let's see. Okay. It will be, the LED will turn on if it's successful. Let's see what's happening. Okay, looks good so far. No, it have some issues. That's an issue. So you didn't put it too far. Okay, good. It should work right now. Next step. Where did you get? So you went to the 4th step. You complete the 2nd step.
Yes.
Perfect. You complete the 2nd step. Let me take a video of you like doing the complete step. That's perfect. So just okay. Hello. Okay, cool. The next step is like we need to send the data to the edge impulse. Before that, you need to install some tools. Like, did you you need to create an edge impulse account? So yeah, you can. Let me just go back and think you can get started. Sorry. You already have the account. That's good. Yeah. You already did it with the edge impulse. Oh, that's good. Good.
Can we accept the project instead collect data by myself?
Yeah, you can collect your data yourself.
No, can I accept the project instead of?
Yeah, sure. So you want my project link? You need to access my project.
Yes.
Okay, let me.
How to find it? Because it takes a lot of time to collect
Yeah. So we already have the collected data. So if you go to the page, you can see we mentioned the data. Let me grab.
I will find.
Yep. Let me. There should be some links where I collected the data
Yeah.
here.
We have. Okay.
Okay. So if you have any issues, you can already use the collected data that I already collected before. So I see people are going. That's good. Okay. The next step should be. So the next step is like we need to send this data to edge impulse. Okay. Because you remember. So in machine learning, what we are doing is like we need to train the data. We need to train the data first. Then only we can use the data, right? So to train the data, we are using a platform called Edge Impulse. So Edge Impulse is a tool where we can upload our data, then do some training, then we can download the like header files for the C++ or C. Okay, cool. For that, now we already have the data here. We have the data. Like let me show you once. So this is the data we have. We are collecting the data, but we don't know. This is meaningless data, right? There are so many data. It's listed there. So we need to like log into first Edge Impulse. So you can create a new account. It's free. You can create a new project if you don't have any. Like I can say Magic Wand Force. Okay, I'll create a new project, Magic Wand Force. So I just need my personal project created. So I have Magic Wand Force. This is my project. Okay, cool. So there's a two method you can do. You can upload the data in two method. One is like you can go here and you can find you can install the CLI command line interface to upload the data. Otherwise, you can go here and click. If you click here, you can download the data set. Okay, cool. So I'm going to download the data set. Before that, the Magic Wand 2. All good? Is your problem fixed? All good? Still? Okay. What's going on here? It's not detecting. Okay. What I can do is I can give you my share. I'll try this. Okay. Thank you. Let me fix this. Yeah, you can give not table like one person. Those are what it's working, right? Okay, perfect. So it has some issues. I actually fixed it. Actually, the NR52 have some two type of bootloader, so it might be skipped sometimes. So that's why. So we can fix that by with a small racer bed, right? You can tap that 2 times, and it will pop up as a as a flash drive. Then we can do the firmware. So that I'm doing right now. So it's fixed. See? Okay, good. So like, yeah,
Yes, he has a error. Okay, so
with the gimbals.
yes,
Okay, this one, right? This is because you don't have the C++ libraries. So what we can do is right now is like, okay, did you try to install this one? Right. So next, what you can do is like, you don't need to go this way. You can do, you can skip this one stage, and you can download the data, then upload directly to the gimbals. Okay, good. So some devices have big issues, so it might be due to the computer. That's why we already have the data. Good.
My library is still installed.
Okay. It will take some time.
Still
that's because
Still wrong.
you install wrong library. So how to
You can go to the sketch,
you need to delete
include library, and manage library. Then you can delete it. There's a button for remove. You can remove. Yeah.
it's the reboot button.
Mm-hmm.
I mean,
So you might receive your magic band with you, right? So you can attach your shower with it. You can attach your shower. We have some tapes, so you can try to attach magic band with the shower. So yeah, try to attach. Yeah. So you can attach. So how many? Like we only give this one. Huh? Okay. Okay. So we have, yeah, that's good. Yeah. Going okay? Okay, perfect. You guys are also trying, right? Okay, yeah, let's start. Start. Yep. Start. Okay. Yeah, and install. Yes. Okay, perfect. This one, embed board, second board. Okay, perfect. It will take a little bit more time since it's a big board. So you got the guide, right? This guide you have, right? Okay, meanwhile it's compiling, you can try to attach the stop stick to the board. It's not a stop stick, it's a magic wand.
hold the delete button here. You need to delete this library.
Let me see, like how. If you want to delete, right?
I use Arduino version.
Okay, it's okay.
Also,
Let me try. Lab, yeah, manually delete. So if you go here, so do you know this one, right?
yeah.
So you can delete. Delete it. Yeah, and did he install the right library? Okay. Then it should be work fine. Let's see. Let's see. Okay. Yeah, try to attach.
This computer shut it down.
What happened?
Will shut it down. This computer will shut it down. Who will shut it down? This computer.
Oh, no battery?
Battery. Yeah.
No battery?
Yes.
You have a charger with you? Oh, that's sad. I was going. How's yours? What happened? You have some issues. That's because you don't the. I think you don't have the library. Okay, so you can go here. Did you install the library? Yeah, you already have the library, right? So what happened? Show BLE embedded sense, right? So combination it's not I mean okay we can remove this one. So it's make some conflict between two libraries. That's why the issue. Now we can try to compare and see if it's working. I'm sure it will work. So try to complete, you will get some prizes. Okay, so try to complete. Really? Yeah, you can try to attach your Xiao.
Yeah,
Able to done?
I think that we miss some part
Hmm?
because
Yeah, you can follow the guide. It's fine.
but we search for the seat do we know that it's not on menu.
Ah, it should be there. Yeah, you need to search for it. Like, where? I didn't get the library.
Yeah, the library.
Yeah, you can like LSM. I think that's the library, right? You said LSM should be here. See the LSM. What do you call it? LSM. What the library name? LSM. LSM D. LSM 6, right? 6D.
Yes,
It should be somewhere here.
DL3.
So LSM D6.
DS3.
DS3.
No.
That's because
No.
it's, you should make it a capital. Yeah. Yep.
The first one.
There should be another one. Seed. Yeah, this one. This is your laptop?
Yeah, his lecture.
Where do you got the stickers?
Yeah.
No.
Just an hour. Just an hour. The workshop.
Yeah. Yeah. Yeah, sure. So yeah, after that, try to upload the data to here. So I'll show you how to do that. Go here and like download the data set from the page. Download the data set from the page. You can download the data set. So here you can see the data set. Okay. Now we are going to the examples part. From here you can see add existing data. So click here, add existing data. Then you can mention upload data. Then choose where the data is coming from. So I'm taking a folder. So I already have the data, like not that one. Basically, just a moment. Like audio model data. But so you need to unzip the file before uploading. So I'm going here. So I need to unzip it like, okay. So now the page is updated. Zipper, let me see which folder. So select a folder, then downloads. This is the folder I am selecting, the data that I already have. Once I click upload, the data should be uploaded here. Okay. And now I need to use upload data. So once we click upload the data, all the data will be uploaded to Edgeimpulse. Okay. You can download the data and upload it. Okay, once you upload the data, you can open here. You can open here and see the data is actually uploaded to the Edgeimpulse. See? So there is a two method. You can collect data directly from the Edgeimpulse because we don't have enough time. We are directly uploading the data. So you can see different kind of data, up and down, idle. When there is the band is not moving, it will be idle. And if it should be an up and down, it's like this. And if it's a left and right, it should be like this. Okay? Okay? Okay, cool. The next step is after you upload the data, you can go to the create impulse. This is where we are actually creating the machine learning part. Okay? So you can sell, this is our input data, the time series data, this is our input. Next, we need to make some processing. What kind of processing are we using? So here we are using the spectral analysis. Spectral analysis we are trying to do because that's actually good for accelerometer. And you can see these are our axes like X, Y, Z. These are our input axes. The next one is we need to do some machine learning part, the algorithm. What kind of algorithm we choose? For that, click here. So here we are using classification. So we need to classify whether it's a left and right, whether it's up and down. Okay. So click classification, then say impulse. So these will be the input data, and we get output as like left, right, or idle. So this will be we get so many data, but we will process, then we'll get these are the output. Okay. Great, save impulse. Then we'll go to the spectral analysis. Now we need to define what is spectral and what kind of power we are using. So here you can see. So far we don't need to change anything to make it simple and generate features. So this part, the spectral analysis try to understand the data. They will do some performance and they will try to differentiate it. Let's see if it can find it. It will take some time. Normally, to do with your computer, you need high power like GPU or something like that in your computer. For now, we are using edge impulse, so we don't need to much more power. Did you upload the data?
Yeah, I don't know how to use it.
You can create login. You can create an account.
I don't have an account.
So yeah, it's uploading the data. So I'm going to make the project to public, so you can also access the data. Yeah, just 3 minutes, okay? It's an answer workshop, that's why. So once you're done with the impulse, like spectral features, you can see the data like this one. See. These are the like a feature explorer. So we can see this will be our up and down, and this will be the idle, and this will be the left and right. So computer trying to distinguish between different data. So that means if it's like this, that means it's good. Computer can easily recognize the difference between different data sets. So that's good. If it's very much mixed, so it's very difficult. So we need to do more performance. After that, you can do to the classifier. The classifier is where we create the artificial neural network. Okay. So here you can see this is our neural architecture, neuron architecture. So you can see we have some input layer, 39 features extracted from here. Then we use like 2 dense neurons, neural layers, and we are like at the last we have some output layers with 3 classes. Okay, and yeah, once you've done, we can try to click. You can see start training. Once we click start training, the machine learning model will try to run different kind of approach. We can try to set how many approach we need to run, etc. So this part is called confusion matrix. How many percentage it actually have false positive or false negative, etc. So you can see it's actually have 100% accuracy. That's good. And you can see the RAM usage, 1.4 KB of RAM only we use, and 15.1 K of flash memory we are using right now with the Shia NR 5840 cents. So that's good. So once you're done with that, you can go to deployment. Okay. And you can click you can search for Arduino, and you can search for the Ion Explorer, and you can click build. So this will generate an Arduino library for you. Okay. Next, what you can do is like, once you're done, you can download the Arduino library. So you can download the Arduino library from here. This is the Arduino library I have. Okay. So I just need to copy the code. You need to add as a zip file. Then I need to copy the code, paste it. Then again, I'm going to upload. So I'm using my own Magic Wand. I think it's somewhere here. So we are running out of time. So try to complete as soon as possible. So now we are uploading the final. Good. You can upload your file. Okay.
No, I can't.
Okay.
No power.
No power. You guys forget your chargers. Okay. Okay. How's it going? You already have color. Yeah, okay, that's good. You can do the classification. For now, you can select the default one. Yeah, go and try it.
So let it work in the default one also.
Yep. So I make it very simple, so you don't need to change the parameters.
Okay.
So okay, I think one person is doing the compilation. That's good. We are at the end. That's good. Okay, you don't need to do that right now, so we can skip that. Like you can go here because it has some issues. It will take some time. So you already done accelerometer, right? Step 2 you already done, right? So now you can go here. You can go here, download the data set, then upload to there. Okay, cool. That will be make easy. Okay. So yeah, it will do. So it will take some time to compile the machine learning library. You can see, yeah, it's almost done right now. So once it's done, we can see the data. Okay, how's it going? Going well? Compilation, right? Yep. You upload the library, machine learning part. Oh, that's good. You are the first one right now. Okay, cool.
Error actually.
Yeah, right.
Here I got some error like no, some file was not there.
Oh, you install everything, right?
Yeah.
File?
Some file.
Okay, let's see. See? Okay, let me show the error, okay?
Yeah, sure.
It shouldn't be there is an error because it's working on cloud. Because we didn't change anything, right? So, yeah. Anyway, yeah. Okay, let's do the compilation. Let's wait. So you can see, I just explained the code, okay? So these are our like libraries that we use. This one from that edge impulse we already generated, and this one from the accelerometer. And these are the some parameter for the accelerometer, like how much force, how much G, etc. And this will be our I2C address. And this is actually the machine learning part is actually happening. You can see here. We are just comparing different like values. See if it can do. Take bit time to compile everything. Oh, you uploaded? That's good. Now we can go to the create impulse. Can you open the edge impulse? And create impulse. Create impulse. Then like you can add a processing data. You can choose as a click there. Yeah, click there. You can choose spectral analysis. That's we are using today's first one. And click in add a learning block. This one here. Then you click on the classification and click save. So now you made the architecture for the examples. Next, you can go to the spectral features. And you can create a generate feature. Yep, and generate feature. Yep, we have part is uploaded. That's good. 4 o'clock, right? We have few minutes left. Try to complete. So this is our final part. Now, if I open the serial monitor, you can see it try to recognize. See, right now the board is okay. I think the algorithm is bit different that I'm using. Okay, not this file we need. Mm, okay, this is not the file we need. Okay, so a few more minutes. Yeah, we can end. Session will start on 4, so we can stop before that. Yeah. Well done. If you're done, you can return the boards there. Okay. Any issues? Okay. If you're done, you can return the boards. Done, right? Yeah. You can put back. You can place your board here once you're done. Okay. Table and sticks. So those are completed like almost. You can distribute the gift or something like that.
Hello, everyone. Well, thank you so much for staying tuned until now for the final sessions of Room 102. And for the final sessions, I want to introduce to you Mr. Masafumi Ohta. He's the founder and representative of Japanese Raspberry Pi user group. And he is also in Japan's and have Raspberry Pi-based project and business in the Asia area. Now he's a moderator the Japan language category on Raspberry Pi official forum. And he's also teaching open source license at Japanese major university. He's now looking into incidents by FOSS license violation to find the practice. And now welcome him with the deep diving to Raspberry Pi 5.
Okay. Thank you very much for coming. Final session for the after session, the final keynote. Please join final keynote afterwards. My name is Masafumi, and I would like to talk deep diving Raspberry Pi. We demonstrate some and to show you to you. Anyway, thank you very much for attending. Many of you know me. This is me and leading a Raspberry Pi community in Japan, and have been collaborating Raspberry Pi over a decade, and spreading words and Raspberry Pi and the use cases and for Asian, not only in Japan. I see many of the bikes. My hobby is riding a bike, and this is my bike, and I took pictures and Japanese lake, and it is a good bike for me. And I rode the bike and over decades. I have talking on many countries talking about Raspberry Pi, and I was talk about automotive grade Linux. If it was a connected car on Raspberry Pi at the Taiwanese and the Raspberry Pi community. I have I hope also the last year I talked at Maker Fair Shenzhen to the Raspberry Pi meetup. See the studio and last session so I hands-on I talk and see the event last year. Today, the theme is first, and talking about. I would like to talking about Raspberry Pi. Now some of you don't know. So now the Raspberry Pi is not sweet and in X because of some of the we discussed it on the issues on the using X. Now, if you get latest information about Raspberry Pi and tech things, and you check them and Mastodon account and the Verilog account, and they notice many more information and about that. And the benchmark at the Taiwanese committee, and the Raspberry Pi 5 is now very much faster than old model. And later I will show some demos about LLM things, and it is very faster than using the Raspberry Pi as a product. And I will get to the detail aspect and looking into the Raspberry Pi. First, you check in the Raspberry Pi, and they now already have button per button. Per button for it's very good for the power of safety. And if you something an issue and using the Raspberry Pi, you can put that on the push the button, and it is same as the active same as activity with the PC, and shut down and safely by software. And debug proof, and now you can see here debug proof is now supported, and supported for the checking a UART serial boot. It is a very important spec for the if you hardware developer, and you can check the firmware booting and be able to debug proof. If still supported only Raspberry Pi OS, and now Ubuntu is under development. For if you use for Raspberry Pi OS, you can see the firmware booting and checking on the PD communication by USB-C and more and the features and by other hardware. And Raspberry Pi 5 very concerned with the Raspberry Pi Pico, and it is an application of the Pico knowledge. And Raspberry Pi is now support has the I/O controller, and it is really same as on the Raspberry Pi Pico. It is it is also, you can check the nearby here, and which memory supported on Raspberry Pi and 5. Some questioning why they don't support 60 gigabyte. I have talked to Raspberry Pi engineers about that. Why they don't support, because it is it is for the package management to so if a single board PC is very small and need to be controlled by easy in small packages, so they cannot support even though PCIe supported 6 gigabytes, but they could not support over 80 gigabyte memories on the Raspberry Pi 4 and 5. And Jeff Garin, American YouTuber, have tried to soldering 6 gigabyte memory and Raspberry Pi 4. It didn't work. He wondering why Raspberry Pi 4 doesn't support, even though PCIe and the support over 6 and up to 6 gigabytes. It is and the packaging issue on the Raspberry Pi 4. It is famous on the Raspberry Pi 5. It is same issue with the Raspberry Pi computer module 4 I/O board. Why USB 2.0? It is an issue in the packages. And it is same issue as the Raspberry Pi 5. Looking deeply for about Raspberry Pi 5 for our committee member and Nishinaga-san try to hack the Raspberry Pi 5 and the JTAG connecting, hacking to the RP1 connected to control and the other by software on Raspberry Pi 5. Why he would like to do that is what he would like to do that is to control I/O by software. So if you are interested, so please check his our website to check that. Sorry, I will actually. Sorry, writing Japanese, and the first time he scared Raspberry Pi engineer banned by him, but and sorry, and writing in Japanese. I hope that someone translating the Google translated, and you can controlling and JTAG. And he interested in Raspberry Pi 4, Raspberry Pi, and using the OpenOCD to build a bare metal OSS. And he soldering, I borrowed his the Raspberry Pi to him. He soldering the data port, and so hacking with OpenOCD too. And he tried to do a control and RPI1 controller with programming. And some of the magazine so misunderstanding it is RP1 port is not like Southbridge. It is programmable controller, but they don't. Raspberry Pi do not disclose it. But I hope they disclose and the RP1 specs to program and the I/O programming by your programmer. So I continue the presentation. Sorry. Sorry, I introduced the detail for the previous blogs and if you're interested in OpenOCD and the bare metal programming and hack Raspberry Pi 5 itself. So, and if you're interested in Raspberry Pi and Chrome OSS, now the improve it. And first time, so many of application doesn't work because it is huge changes on the build core 7 processor and the GPU processor and more. And first time it does Vulkan doesn't work, and why I was testing as field testing. Now I suppose there's many more applications background, but please be careful. And so if you are developer with Python and Debian, not Raspberry Pi OS, Debian bookworm not recommended using a pip. You know, so if you use the pip install and so you got the error message say Debian now and not recommended using a PIP. So if you are developer and something Python development with Raspberry Pi, and you should use apt or VM, virtual environment. So please be careful for you and developing your Raspberry Pi on with Raspberry Pi OS on Python, and so different and more. I have noticed there's something different of a SVC board. I have using a Jetson, Local, and some other SVC board. And what is the difference with from other SVC board is almost such SVCs based on Debian and Linux Debian itself. But all Raspberry Pi is recompiling recompiling for the Raspberry Pi itself, and it is checked and customized and suitable for Raspberry Pi. So you can feel safety use on Raspberry Pi rather than other OSs. It is the point. And why? And so Raspberry Pi supports many things. And RTC and a really important element. And so it is a request for many more enterprise users. Why RTC is needed for the B2B enterprise business? Sorry, I will not bothering such a Shenzhen product. I have checked for GPD Pocket 2 or some other Shenzhen and low-end PCs doesn't have this. I checked for the GPD Pocket and Chewy and some Chewy to the install on Linux. I got a trouble to so file battery is empty and time reset and so readjust. I have to readjust the time for it. And I checked the cover to this and I looking for this artistic and they don't have it and thus I have to readjust. It is not good for the B2B users. So and the B2B users request and this RTC unit. And Osakura is now not. If I say it's not mandatory, so because a BCM 2712 is now improved, and it is the control the heat cooling. So when it is idle, for the cooler is stopped, and for safe using. So I checked the field testing for the security fan. So if idling, fan is stopped. Fan stops. So I was very wondering about that, but it is good and only heat sink and makes cool and the CPUs. It is improved on the Broadcom SOC features, but Ubuntu doesn't support it. So you might check and so Ubuntu development and check the details. So, and now, if you using Ubuntu and fun and running, if CPU is idle, and I have not recommend. And I don't recommend. Sorry, I don't recommend using expensive SD card. I checked the field. I have checked the field at the field testing, and so checking it for the many more FD curves, and benchmarked, and I and the field testing members in our committee and found it is up to 60 megabyte per second. It is basically SD cards can be freed using Raspberry Pi 5. You should not expensive SD card and the whole Raspberry Pi 5. And some people check this out like me, but I do not recommend these expensive cards. And so some of enterprise users know, and the SD cards and not good for the enterprise using for SD, and I have been talked to many times for a long time. So they talked about the Raspberry Pi engineers about the boot system and what boot system good and using a Raspberry Pi. And now supporting with PCIe and Express, and they using mainly using for the booting, NVMe and the SD card. There are several booting and the ways and for using a Raspberry Pi. And I think it may be better for now NVMe and the low-end classes and get much cheaper for and more. Such SD card and such an NVMe card and the board is not so cheap and not so expensive. So I recommend, especially in the enterprise and B2B use, and I recommend using this and such a NVMe card. And it is very, very annoyed issue using on the AC adapter on Raspberry Pi 5. Why? It is annoyed, and it is only have on the table and the 5 volt 5 amperes. And Raspberry Pi 5 recommended 5 volt 5 amperes. And it is very, very specific and PD features only. And so I do not recommend. I recommend to using the AC adapter, and I do not recommend such electric charger, but it works. And it works good. It works fine. But I do not recommend multiple adapters and once using adapters for the PD resetting to reconnect to the PD communication. So I will not recommend such a PD and multiple adapters. And next features on it. Raspberry Pi weakest point is using AI. Sony kindly developed the cameras and the IMX 500 and using whole AI, including the Cortex M3 chip on it. It is analyze the object to upload to so analyze in the edges or the cloud. And Raspberry Pi planning to combine with such Sony's and the AI cameras with the Raspberry Pi. It is something game changer for me. So and fine, sorry, and I don't have any time on it, and so I would like to have a time. Sorry for that. sorry, hold on a second. I would like to show a bit using the tiny LLM. If you use but you should check. You should check the LLM and the tiny LLM and the website. For I check the time. I check the time to the tiny LLM and the question and the Raspberry Pi and in average or within the 10 or the 5 seconds. It is a point. And on the other hand, if you use a Raspberry Pi 4 or other regular or something, and the answer is, well, 4 minutes. Sorry, 40 minutes. Sorry, 2 minutes. 2 minutes ago. So go, sorry. Yes. So check it back the presentation. So please this is a final say, right? So please and purchase ocean reseller. There are some, and I heard especially in the Asian area, and there are many and more purchasing issue. And so purchasing Raspberry Pi on the Taobao on the Amazon.com website. It is double expensive than Raspberry Pi ocean reseller. So please and purchase in the Raspberry Pi referrals and ocean reseller on that. I recommend to do that. So I would like to introduce Ban coming here. Sorry, is the Vietnam. Let me just sorry, you can talk in Vietnamese.
Okay, hello everyone. So this is Van, and I'm from Vietnam. So we are Citron Technologies, and our headquarters is in Malaysia. So we are the authorized reseller of Raspberry Pi in Southeast Asia, including Malaysia, Singapore, Thailand, and recently Vietnam. So besides Raspberry Pi, we also the authorized resellers of Arduinos and Microbit. Yep. So besides the tradings, we do manufacturing our own products based on the Raspberry Pi compute module 4 from Raspberry Pi, or based on the Artimega processor from Artimega for sure. And we do develop our products. Also come with guidebook for microbit learning solution. So we have some product that is for people, for students from primary to secondary and to university level. Yeah. So if you are interested in the product, you can head out to citron.io to explore more. Yeah. Thank you. Thank you, Masafumi.
Thank you very much for your introduction. So thank you. So you please ask the bound to the purchase Raspberry Pi in the Vietnam and Malaysia and from India. So thank you very much for attending. And any questions? So I am welcome to answer. Okay.
All right, everyone. So these sessions will be closing now, and this will be the final sessions for today in this room. So now, please, you can head to the main hall to take part in for the last of all the sessions today. Thank you so much again.